Hi, so we're solving this problem, non-homogeneous problem, by taking the Laplace transform. So we'll take the Laplace transform of all terms. But first, some of the important formulas we're going to be using, given known formulas, are that we can rewrite this as capital Y of S, the Laplace transform of Y, and that Laplace transform of Y double prime is equal to Y of S minus S of 0 minus Y prime is 0. And the Laplace transform of Y, or of sine of AT, is equal to A over S squared, A over S squared plus A squared. And so to begin, we'll just take the Laplace transforms of all sides, all terms, plus, and we can bring out the 4 because of its linear property. We'll go do that. And on the right side, we can bring out the 6. Sine of 2t. And now we're gonna just plug in the formulas we have up here, and also our initial conditions that were given to us here, in order to simplify. So we're gonna get Y of S minus S times Y of 0 is just 1, so it'll be just 1, minus Y prime of 0, which is a 0, plus 4. So now 4, because we brought out the 4 times the Laplace transform of Y, which is just Y of S, and this is equal to bring out the 6, and the Laplace transform of sine of AT is and our A here is 2 because it's 2t, so it'll be 2 times S squared plus 4. And now we can simplify the right side and also drop the zeros, so we'll be left with this. And now we can, in order to solve for YS, the Laplace transform of Y, we have to isolate it, so we can group its terms together, bring it out in the front. To continue isolating, we can add S to both sides. And now we can divide by, to isolate it, we can divide by S squared over 4, so it'll be S over plus 4 plus 12. And since the denominators match, we can just square it. And now, in order to find Y of t, in order to go back, we have to use the inverse Laplace transform, because Laplace transform from a function of Y of t into a function of S. So to go backwards, we just take the inverse. So then our Y of t is given by S over S squared plus 4 plus 12 over S squared plus 4 squared. And for our first inverse here, we can see that this matches up from another standard formula of the Laplace transform of cosine of A of t is equal to S over S squared plus A squared. So this matches up with that transform, so we can rewrite where our A is 2. So this is just cosine of 2t, and this is a repeated, since again it's a repeated denominator, we have to use from the formulas, we have to use the repeated quadratic formula for this one, which is that the Laplace transform of 1 over 2a cubed sine, and this is also given in the standard formulas. At cosine of at is equal to 1 over s squared plus a squared squared. And our a here is going to be, our a here, since this is squared, so 4 is equal to a squared, so a is equal to 2. So given that, we can rewrite that as 12, because we can just bring out the 12 and times 1 over 2a cubed, which is 1 over 2, and our a is 2, times sine of at, our a is again 2, and minus at, which is 2t cosine of 2t. And we can simplify the fractions, 2 times 2 cubed to 16. So we're just going to end up with, and then also we're going to end up with, and we can also simplify the 12 over 16 to 3 over 4. So this will just be 3 over 4. 2t minus 2t cosine of 2t. And we can distribute the 3/4 to both terms, so we'll just get 3/4 sine of 2t minus 3/4 minus 3/4 times 2t cosine of 2t, and this will just end up being 3 over 2t cosine of 2t. So our final answer, we can combine that our y of t is equal to cosine of 2t, what we got earlier, plus what we got right now, 3/4 sine of 2t minus 3/2 t cosine of 2t. And that would be our final answer. Thank you.